Alright, let's look at the process of Sgl Spike standard addition. What we have here is a situation where we have a sample that may have some matrix complications, meaning that the signal that we're measuring may not be just because of the analyte that we care about. And so if we're not really sure what's going on in the background, then standard addition is a really good way of managing this. So let's look at what these variables mean. The first thing means this is our analyte, and notice that they use a subscript that's either I or F, meaning initial or final concentration, and we'll look at what that means in just a second. We have a concentration of a standard of the same analyte. So this is just a known concentration of analyte. And we have intensity. So this is just a signal value. Now they call it intensity because they're not really sure what kind of equipment you're working with. Maybe you're looking at absorbance, maybe you're looking at voltage, whatever it is that you're measuring, we could call that response to the concentration and intensity value. So what we've done is we took our original sample, our initial sample of our unknown, and we measured the intensity or the signal that it gives. And then we added a small amount of a standard to our sample. And because we added a new volume, we've now changed our concentrations. So our concentration of our final concentration is a dilution, the volume of the standard that we used compared to the volume total, times the original concentration of our standard. So because we mixed volumes, we've diluted our standard. But we've also diluted our unknown. So we could also say that the concentration final for our unknown is the volume original of our unknown compared to the volume total times the original or initial concentration of our unknown. So here we have a VO, which is the original sample volume. We've got a VS, which is the volume of the spike of the standard. You might wonder why they call that a spike. If I told you that I spiked your drink with rum, then I'd be telling you that I added a certain amount of rum to it. And so that really is what that represents. We've added some volume of the sample to it. And then we have some final volume of our mixture. So, in order to do this, what we really want to know is what is this. So we're going to have to do a little bit of algebraic magic. Now, I do the algebraic formulations and I walk through it explicitly because if we have to use a spreadsheet, then we would need to tell the spreadsheet what to do in one or two steps. So this derivation is really so that we can use a spreadsheet more effectively. So what we're going to do is we're going to substitute in terms of these two based on the original amounts. So I know my xi has not changed. This one has changed. It's the volume of the spike over the total volume times my concentration of my initial standard. I have an original volume over the total volume times my original or initial concentration, and that will have to equal the intensity of the signal of my unknown compared to the intensity of the signal with the standard on board. Now again, what we're trying to find is a concentration of our unknown, so we're going to have to do a little bit of algebra just to isolate those unknown terms. So the first thing I'm going to do is cross multiply times ix plus x equals ix times the group Vs over V times Si plus VO over V times Xi. Alright, now I'm going to go ahead and isolate this. I'm going to move this over to the other side, just because it's a single term. Xi equals Ix over Ix plus S times now Vs over V times the concentration initial of our standard plus VO over V times our Xi. Now I know that I need to get my X terms together, which means that I'm going to have to distribute so that I can isolate this term. So let's go ahead and distribute this to all of them. Xi equals Ix over Ix plus S distributing to the first term, Vs over V times Si plus, again, this intensity ratio, Ix over Ix plus S times our volume ratio times Xi. So now we're going to move this Xi term all the way to the left side. Xi minus Ix over Ix plus S times VO over V times the concentration of Xi equals Ix over Ix plus S times Vs over V times the concentration of our initial standard concentration. So now let's factor out our Xi term, and that's got to equal our intensity term times our volume term so we have now isolated now if you look carefully, this term is our SF, but now we've got it in a form that we can work with. Now you might wonder why I've gone through all of this nonsense in order to solve for an unknown. And the answer is, if I solve explicitly in terms of variables, then I can create a spreadsheet in Excel where I can just enter what the variables are and easily enter a formula. I can see that the variables are going to be my initial volume, the volume of my spike, my intensity of my original sample, the intensity of my sample with the spike, and I can solve for a volume total, and I can solve for a concentration of X initially. So these were things that changed with the experiment, and based on this data, I can find this data. So let's go ahead and set up a spreadsheet that will do this for us. Now you might again wonder, why would you bother doing this? And the answer is because we use this technique of single addition over and over and over again. And so if I set up a template in my spreadsheet, then I don't have to recalculate it every time. So let's look at our spreadsheet and let's see what we can put in here. So again, this is going to be a single spike standard addition. And we have a volume of our sample. We have our volume of our spike. We have our concentration of our standard initially. We have an intensity of our unknown, and we have an intensity of our unknown with the standard. and then we can do some calculations. So we're going to need to know what is VT, and we can see that the volume total will be the volume original and the volume of our spike. And we can see then, by substituting in our calculations, how to solve for x. Now, I typically do these in small chunks. I can see, for example, that this ratio of Ix over Ix plus x is used a couple times. So I typically do some intermediate calculations. And the reason I do this is so that if I have a typo, I can fix it easily and I can find it easily. So my ratio of my unknown intensity over my known and unknown intensity is there. I have a ratio of volume standard over volume total, which is equal to volume standard over volume total. I have a ratio of our original sample compared to the original volume, and that's going to equal our original volume over our volume total. And so now I can set up my unknown value. So my unknown is going to equal this ratio, intensity ratio, times the spike volume ratio, times the concentration of my spike, over the group 1 minus the intensity ratio times the volume original over total. Close that group, and we can solve for our unknown. Now right now that doesn't look like very much, but what this means is that any time I have a single spike standard addition, all I have to do is enter the parameters and it will do our calculation for us.